Hey everybody, in this video we're going to talk about completing the square of a quadratic equation. And when we complete the square, what we're doing is we're turning any given quadratic equation into a perfect square trinomial. And a perfect square trinomial is a quadratic equation that has a couple nice properties to it. The perfect square trinomial might look like x squared plus 10x plus 25, or it might look like something like x squared minus 8x plus 16. So what makes these things perfect square trinomials? Well, our first term and our last term are both squared values, right? So 25 is the same as 5 squared. 16 is the same as 4 squared. So we've got the first and last terms are squared values. And this middle term, this has a unique relationship of being double the base of our last term. Or in other words, we could take 10 divided by 2 and we get 5. That's what we're squaring in the last term. We could take our negative 8 divided by 2 and we could get negative 4. And when we square that, we get we get 16. So that's one unique piece, or one way that you can identify these the perfect square trinomials. Another way is how they factor. This 4 should actually be negative, shouldn't it? But the way they factor is you get x plus 5 squared, or you get x minus 4 squared. So you notice that the half, like if you cut that middle term in half, you get your second term in your parentheses that are squared. So these things we've talked about a little bit in the factoring video, so you can go back and look at that video if you want to know how to factor these things to get them down to these nice parentheses. But we're not going to go into that here. Or it's going to go on the assumption that you understand how to do that. So let's look at an example of how we can turn any equation into a perfect square trinomial. So let's start with x squared minus 12x equals 3. So even if we brought this 3 over to the other side of the equation, that would not be a perfect square because 3 is not a squared number. So what we're going to do is we're going to focus on this negative 12. And we're going to say, well, negative 12 divided by 2 is negative 6. So we know when we factor it, that's going to be the piece that's going into our parentheses. But what we have to do is we have to add the squared piece, the square of negative 6, which is 36, to both sides of the equation. So now when we do that, x squared minus 12x plus 36 equaling 3 plus 36, that left side is that perfect square. 36 is 6 squared, or negative 6 squared. Negative 12 divided by 2 is negative 6. So now we have a perfect square on our left side, x minus 6 squared. On our right side, we have 39. Now, how are we going to solve this? We're trying to find the value of x, the solution of x that makes this happen. So we're going to take the square root of both sides. Okay? So as we take the square root of both sides, we're going to get x minus 6 equals plus or minus, that's actually plus or minus the square root of 39. Now we do a plus or minus in there because we are taking the square root of an x squared value, so we have to consider both the positives and negatives there. So make sure that you always do that plus or minus in there. So now as we add 6 to both sides, we get 6 plus or minus square root of 39, and we've got our solution. Easy as that. That's the value of x that would make this whole thing equal 3 up at the beginning. So let's look at another example. Let's say we've got x squared minus 3x minus 1 equals 0. Okay, so now here we've got a negative 1 at the end. So while 1 is a squared number, negative 1 is not a squared value. Notice up in the first example in the black, 8x squared minus 8x plus 16. That's a positive 16. So negative 1 is not going to be a squared number. So we're going to move that to the other side of the equation. Leave a little space. So what we need to do is we need to take our middle term, which is that negative 3x, and divide that by 2. So negative 3x divided by 2, well, we'll just leave it at negative 3 halves. All right, nice and easy. So we take that, we square it, and that's what we're going to add to both sides of the equation. So we're going to add negative 3 squared, which is 9/4. So that's going to get added to both sides of the equation. Now I've already determined, again, just like in the previous examples, the thing that's going to be in our parentheses is going to be that that second or that middle term divided by 2. So we get x minus 3 over 2 squared, and then we have to add together the left side, so we can change that 1 to 4 over 4. What's that? 13 over 4. So we've got our two sides. We're going to take the square root of both sides. We get x minus 3 over 2 equals plus or minus square root of 13 over 2. So remember that square root goes on the top and the bottom of your fraction. Square root of 4 is 2, so we've got that there. Add our 3 halves to both sides, and we get 3 halves plus or minus square root of 13 over 2, and we've got our solution. All right, let's look at one or two more examples real quick. 2x squared plus 8x equals 6. All right, so first thing, even before we get started, this one's a little different. Notice that each of these is an even number, therefore each of these is divisible by 2. So that's always a good thing to do anytime you're working with quadratic functions or quadratic equations. Look to see if there's a common factor amongst everything. All right, so we could divide both sides by 2 and we get x squared plus 4x equals 3. Now that doesn't give us a perfect square trinomial, but it does give us some numbers that are a little bit easier to work with. So we're going to take this 4, we're going to divide it by 2, and we get 2. We're going to take that 2 and we're going to square it, and that's what we're going to add to both sides of the equation. So we'll add 4 to both sides. We're going to factor our left side, so we get x plus 2 squared equaling 7. Take the square root of both sides, so we get x plus 2 equals plus or minus square root of 7. Bring that 2 over to the other side, so we get negative 2 plus or minus square root of 7. So hopefully this process is getting a little bit easier. Hopefully you're recognizing some of the patterns here. Let's look at one last equation. So we got 4x squared minus 20x equals 5. All right, so this one's most unique out of all of these. So if we look across the whole equation, we can notice that there's nothing common amongst everything, but there is something common on the left side. We could factor out a 4 from the left side, and we get our x squared minus 5x equaling 5. So this makes it a little bit nicer of a number to deal with as we're completing our square. So we're still going to take our negative 5, and we're going to divide it by 2. We're going to square it, get our 25 over 4. So that's what we're going to add to both sides, right? 25 over 4. However, notice that this 25 over 4, this is inside of parentheses. So that's actually being multiplied by 4. So we're not adding 25 over 4 to both sides. We're actually adding 25 over 4 times 4, which is 25. Right? So if you took that 4 on the outside of the parentheses and multiplied it across, you would see that you're actually adding 25 to both sides. So we need to make sure that we account for that. This is the biggest trip up that people have when they're doing these types of things. That if you factor out a number before you start completing the square, you have to make sure that you multiply that number back in so you truly are keeping the equation balanced on both sides. Okay, so make sure that you're doing that, especially if you factor first. Okay. So now we've got 4 times x minus 5 over 2 squared equals 30. And we can move our 4 to the other side. X minus 5 over 2 squared equals 30 over 4. Take our square roots of both sides, and we end up with x minus 5 over 2 equals plus or minus root 30 over 2. Again, remember that the square root goes on the top of in the numerator and in the denominator. Since we know the square root of 4, we know it's going to be 2, and we've got our solution there. So just make sure that you are accounting for all possibilities. Sorry, I forgot to add 5 halves over to the other side. Make sure that you're accounting for everything that you're adding to both sides, and that you're not actually shortchanging yourself like you might do in the purple equation here. So that's how you complete the square with a number of examples there. I hope this helps, and we'll be talking about the quadratic formula in the next video. Talk to you then.